Gods and Demons, Pythagoras. In context, key figure Pythagoras, circa 570 to 495 BC. Applied geometry is the field. Before, circa 1800 BC, the columns of cuneiform numbers on the Plimpton 322 clay tablet from Babylon include some numbers related to the Pythagorean triples. 6th century BC, Greek philosopher Thales of Miletus proposes a non-mythological explanation of the universe, pioneering the idea that nature can be interpreted by reason. Circa 380 BC, in the 10th book of his Republic, Plato espouses Pythagoras' theory of the transmigration of souls. Circa 300 BC, Euclid produces a formula to find sets of primitive Pythagorean triples. The 6th century BC Greek philosopher Pythagoras is also antiquity's most famous mathematician. Whether or not he was responsible for all of the many achievements attributed to him in math, science, astronomy, music, and medicine, there's no doubt that he founded an exclusive community that lived for the pursuit of mathematics and philosophy and regarded numbers as the sacred building blocks of the universe. Pictured here, Thales of Miletus, one of the 7 sages of ancient Greece, possibly inspired the younger Pythagoras with his geometrical and scientific ideas. They may have met in Egypt. Angles and symmetry. The Pythagoreans were masters of geometry and knew that the sum of 3 angles of a triangle, 180 degrees, is equal to the sum of 2 right angles, 90 angles and 90 angles, a fact which 2 centuries later was described by Euclid as the triangle postulate. Pythagoras' followers were also aware of some of the regular polyhedra. These are the perfectly symmetrical 3-dimensional shapes such as the cube that were later known as the Platonic solids. Pythagoras himself is primarily associated with the formula that describes the relationship between the sides of a right-angled triangle. Widely known as the Pythagorean theorem, it states that a squared plus b squared equals c squared, where c is the longest side of the triangle, the hypotenuse, and a and b represent the other 2 shorter sides that are adjacent to the right angle. For example, a right-angled triangle with 2 shorter sides of lengths 3 inches and 4 inches will have a hypotenuse of length 5 inches. The length of this hypotenuse is found because 3 squared, 9, plus 4 squared, 16, equals 25. Such sets of whole number solutions to the equation a squared plus b squared equals c squared are known as Pythagorean triples. Multiplying the triple 3, 4, and 5 by the power of 2 produces another Pythagorean triple, 6, 8, and 10. By 2 produces another Pythagorean triple, 6, 8, and 10. 36 plus 64 equals 100. The set 3, 4, 5 is called a primitive Pythagorean triple because its components share no common divisor larger than 1. The set 6, 8, and 10 is not primitive as its components share the common divisor 2. There is good evidence that the Babylonians and the Chinese were well aware of this mathematical relationship between sides of a right-angled triangle centuries before Pythagoras' birth. However, Pythagoras is believed to have been the first to prove the truth of the formula that states this relationship and its validity for all right-angled triangles, which is why the theorem takes its name. Pythagorean triples. The sets of 3 integers that solve the equation a squared plus b squared equals c squared are known as Pythagorean triples, although their existence was known long before Pythagoras. Around the year 1800 BC, the Babylonians recorded sets of Pythagorean numbers on the Plimpton 322 clay tablet. These shows that triples become more spread out as the number line progresses. The Pythagoreans developed methods of finding sets of triples and also proved that there is an infinite number of such sets. After many of Pythagoras' schools were destroyed in the 6th century BC political purge, Pythagoreans emigrated to other parts of southern Italy, spreading their knowledge of triples across the ancient world. 2 centuries later, Euclid developed a formula to generate triplets. A equals m squared, n squared, b equals 2mn, c equals m squared plus n squared. With certain exceptions, m and n can be any 2 integers, such as 7 and 4, which produce the triple 33, 56, 65. 33 squared plus 56 squared equals 65 squared. The formula dramatically sped up the process of finding new Pythagorean triples. Above here, the graphic demonstrates why the Pythagorean equation a squared plus b squared equals c squared works. Within a large square, there are 4 right-angled triangles of equal sides labeled A, B, and C. They are arranged so that if tilted square is formed in the middle by the hypotenuse c-sides of the four triangles. Journeys of discovery. Pythagoras was well-traveled, and the ideas he absorbed from other countries undoubtedly fueled his mathematical inspiration. Hailing from Samos, which wasn't far from Miletus in western Anatolia, present-day Turkey, he may have studied at the school of Thales of Miletus under the philosopher Anaximander. He embarked on his travels at the age of 20 and spent many years away. He is thought to have visited Phoenicia, Persia, Babylon, and Egypt, and may also have reached India. The Egyptians knew that a triangle with sides of 3, 4, and 5, the first Pythagorean triple, would produce a right angle, so their surveyors used ropes of these lengths to construct perfect right angles for their building projects. Observing this method firsthand may have encouraged Pythagoras to study and prove the underlying mathematical theorem. In Egypt, Pythagoras may have also met Thales of Miletus, a keen geometrician, who calculated the heights of pyramids and applied deductive reasoning to geometry. Reason is immortal, all else is mortal. Pythagoras. A Pythagorean community. After 2 decades of traveling, Pythagoras eventually settled in Crotone, now Crotone, southern Italy, a city with a large Greek population. There he established the Pythagorean Brotherhood, a community to whom he could teach both his mathematical and philosophical beliefs. Women were welcome in the Brotherhood and formed a significant part of its 600 members. When they joined, members were obliged to give all their possessions and wealth to the Brotherhood and also swore to keep its mathematical discoveries secret. Under Pythagoras' leadership, the community gained considerable political influence. As well as its theorem, Pythagoras and his close-knit community made numerous other advances in mathematics, but carefully guarded that knowledge. Among their discoveries were polygonal numbers. These, when represented by dots, can form the shapes of regular polygons. For example, polar is a polygonal number as 4 dots can form a square, and tail is a polygonal number as 10 dots can form a triangle with 4 dots at the base, 3 dots on the next row, 2 on the next, and 1 at the top of the triangle. 4 plus 3 plus 2 plus 1 equals 10. 2 millennia after Pythagoras, in 1638, Pierre de Fermat enlarged on this idea when he asserted that any number could be written as the sum of up to k gonal numbers. In other words, every single number is the sum up to 3 triangular numbers, up to 4 square numbers, or up to pentagonal numbers, and so on. For example, 19 can be written as the sum of 3 triangular numbers. 1 plus 3 plus 5, 15 equals 19. Fermat could not prove this conjecture. It was only in 1813 that French mathematician Augustin Louis Cauchy completed the proof. Strength of mind rests in sobriety, for this keeps your reason unclouded by passion. Pythagoras. Fascinated by numbers. Another type of number that excited Pythagoras was the perfect number. It was so called because it is the exact sum of all the divisors less than itself. The first perfect number is 6, as its divisors 1, 2, and 3 add up to 6. The second is 28. 1 plus 2 plus 4 plus 7 plus 14 equals 28. The third, 496, and the fourth, 8,128. There was no practical value in identifying such numbers, but their quirkiness and the beauty of their patterns fascinated Pythagoras and his brotherhood. By contrast, Pythagoras was said to have an overwhelming fear and disbelief of irrational numbers, numbers that cannot be expressed as fractions or of 2 integers, the most famous example being pi. Such numbers had no place among the well-ordered integers and fractions by which Pythagoras claimed the universe was governed. One story suggests that the fear of irrational numbers drove his followers to drown a fellow Pythagorean, Hippasus, for revealing their existence when attempting to find the square root of 2. Pythagoras' reputation for ruthlessness is also highlighted in a story about a member of the Brotherhood who was executed for publicly disclosing that the Pythagoreans had discovered a new regular polyhedron. The new shape was formed from 12 regular pentagons, known as the dodecahedron, one of the 5 Platonic solids. Pythagoreans revered the pentagon, and their symbol was the pentagram, a 5-pointed star with a pentagon at its center. Breaking the Brotherhood's rule of secrecy by revealing their knowledge of the dodecahedron would therefore have been an especially heinous crime punishable by death. The finest type of man gives himself up to discovering the meaning and purpose of life itself. This is the man I call a philosopher, Pythagoras. In the School of Athens, pictured here, painted by Raphael for 2 years, from 1509 to 11, for the Vatican in Rome, Pythagoras is shown with a book surrounded by scholars eager to learn from him. I have often admired the mystical way of Pythagoras and the secret magic of numbers. Sir Thomas Browne, English Polymath. An integrated philosophy. In ancient Greece, mathematics and philosophy were considered complementary subjects and were studied together. Pythagoras is credited with coining the term philosopher from the Greek philos, love, and sophos, wisdom. For Pythagoras and his successors, the duty of a philosopher was the pursuit of wisdom. Pythagoras' own brand of philosophy integrated spiritual ideas with mathematics, science, and reasoning. Among his beliefs was the idea of metempsychosis, in which he may have encountered on his travels in Egypt or elsewhere in the Middle East. This held that souls are immortal and at death transmigrate to occupy a new body. In Athens 2 centuries later, Plato was entranced by the idea, included it in many of his dialogues. Later, Christianity too embraced the idea of a division between body and soul. Pythagoras' ideas would become a core part of Western thought. Importantly for mathematics, Pythagoras also believed that everything in the universe related to numbers and obeyed mathematical rules. Certain numbers were endowed with characteristics of spiritual significance and what amounted to a kind of number worship, and Pythagoras and his followers sought mathematical patterns in everything around them. Numbers in a harmony. Music was of great importance to Pythagoras. He is said to have considered it a holy science. Rather than something simply to be used for entertainment. It was a unifying element in his concept of harmonia, the joining together of the cosmos and the psyche. This may be why he is credited with discovering the link between mathematical ratios and harmony. It is said that walking past a blacksmith's forge, he noticed that different notes were produced when hammers of unequal weight were struck against equal lengths of metal. If the weights of the hammers were in exact and particular proportions, their resulting notes were harmonic. The hammers in the forge had individual weights of 6, 8, 9, and 12 units. Those weighing 6 and 12 units sounded the same notes at different pitches. In today's music terminology, they would be said to have an octave apart. For the frequency of the note produced by the hammers of unequal weight were struck against equal lengths of metal. If the weights of the hammers in the forge, the frequency of the note produced by the hammer of weight 6 was double that of the hammer weighing 12, which corresponds with the ratio of their weights. The hammers of weights 12 and 9 produced a harmonious sound, a perfect fourth, as their weights were in the ratio 4-3. The notes made by the hammers of weights 12 and 8 were also harmonious, a perfect fifth, as their weights were in ratio 3-2. Contrast, the hammers of 8, 9, and 8 were dissonant, as 9, 8 is not a simple mathematical ratio. By noticing their harmonious musical notes were connected to numerical ratios, Pythagoras is the first to uncover the relationship between mathematics and music. In this picture, Pythagoras was reputedly an excellent lyre player. This drawing of ancient Greek musicians illustrates two members of the lyre family, the trigon to the left and the cithara, creating a musical scale. Although scholars have questioned the story of the forge, Pythagoras is also widely credited with another musical discovery. He is said to have experimented with notes of by lyre strings of different lengths. He found that while a vibrating string produces a note with frequency F, having the length of the string excuse me. Okay. Having the length of the string produces an octave higher with frequency 2F. When Pythagoras used the same ratios that produced harmoniously sounding hammers and applied them to vibrating strings, he similarly produced notes in harmony with one another. Pythagoras then constructed a musical scale starting with one note and the note with an octave above it, filling in the notes using perfect fifths. The scale was used until the 1500s when it was replaced by the even-tempered scale, in which the notes between the two octaves are more evenly spaced. Although the Pythagorean scale worked well for music lying within one octave, it was not suited for more modern music, which was written in different keys and extended across several octaves. While there have been many different types of musical scales in use by different cultures, the long tradition of Western music dates back to the Pythagoreans and their quest to understand the relationship between music and mathematical proportions. Above, the numerology of the Divine Comedy by Dante, 1265 to 1331, pictured here in a fresco from the Duomo in Florence, Italy, reflects the influence of Pythagoras, who Dante mentions several times in his writings. Oh. Dad, stop. I'm focusing. The legacy of Pythagoras. Pythagoras' status as the most famous mathematician from antiquity is justified by his contributions to geometry, number theory, and music. His ideas were not always original, but the rigor with which he and his followers developed them using axioms and logic to build a system of mathematics was a fine legacy for those who succeeded him. There is geometry in the humming of the strings. There is music in the spacing of the spheres. Pythagoras was born around 570 BC on the Greek island of Samos in the eastern Aegean Sea. His ideas have influenced many of the greatest scholars in history, from Plato to Nicholas Copernicus, Johann Kepler, and Isaac Newton. Pythagoras is thought to have traveled widely, assimilating ideas from scholars in Egypt and elsewhere in the Middle East before establishing his community of around 600 people in Croton, southern Italy, around 518 BC. This aesthetic brotherhood required its members to live for intellectual pursuits while following strict rules of diet and clothing. It is from this time onward that his theorem and other discoveries were probably set down, although no records remain. At the age of 60, Pythagoras is said to have married a young member of the community, Theano, and perhaps had two or three children. Political upheaval in Croton led to a revolt against the Pythagoreans. Pythagoras may have been killed when his school was set on fire or shortly afterward. He is said to have died around 495 BC.